Hello and welcome to my class. I'm Grolin Annesley from ThinkMo Education. I'm currently a Cisco Technological lecturer. If you like my video, welcome to my study group. Or contact my teaching assistant. WhatsApp account is +658 3444 290. Today's topic is the basic concept of network. An OSI 7-layer basic model. Before starting class, let me first introduce to you. Actually, what we learn in the CCNA stage is relatively simple. We are more focused on an understanding of the basic framework of the network and some simple commands. For example, assign an address, run a simple protocol, knock some simple VLANs, including ACL and NAT, which we will cover in the last lesson. Then let's practice typing a configuration. More than that, I hope everyone can lay a good foundation. Okay. We are now officially starting classes. Today we are more focused on knowledge of network infrastructure. That is the basic concept of the network. And a brief introduction to the OSI 7-layer model. First, I hope you all know. We now learn the main purpose. In fact, it revolves around 1. Communication of overall data, or network communication. For example, let's take a relatively simple question. For example, this is my device on the left, the teacher's computer. I connected to the server of the teaching platform. I'm giving a lecture. You may be listening to my lecture on your phone or computer. Is that actually understandable now? Here are the students. I'm equivalent to right now from my device. Produced a data. I use the teaching platform to generate a data. So in the future this data, with the help of the network we have already built, pass it on to the students. So what we call data communication actually means I have generated a data on one of my devices. The future relies on our overall network. The process of sending to everyone's side. We call this process network communication. In fact, this process, it's very similar to sending a courier. I will send you a courier. Then after I pack the courier with intermediate logistics, the process of reaching the hands of the students, we call it data communication. But for us, everyone will find, overall it sounds simple. I send a data and you receive it. But what we have to learn is, why do you receive? Why does my device generate a data? You can receive. That's like a courier. Why after packing? Hand over to our logistics center. It can reach its destination. This will tell us a framework problem of the overall network. So let's start with the basics today. Explain our current online world. We call it a world where everything is connected. How is it made up? Let's take a look together. Give a relatively simple example. We will draw later. If I now draw a picture like this sideways, then draw a device on my behalf. This device is called a switch. Today we will not talk about its communication principle. Just follow my rhythm. For example, let's take a small company as an example. So as a company, these squares I'm drawing now is a PC. We have a lot of office staff. In the future, many employees will use such a computer. Let's set up a simple network for it first. In the future, we will pass the network cable one by one. Connect it to the intermediate switch. This forms a minimal network. Just this network. We say it can only communicate within the network. We can't go online. But we also formed a network. That is to say, everyone will find out in the future. Between my computer. If you want to communicate with each other, we have to connect. That is, we have to insert a network cable in the middle. In other words, I want to communicate between my devices. I want to make sure this device is near me. Or we want to connect. So we will go through some lines in the future. We pass some relays in the middle. That is based on such a relay device plus a link. Realize the interconnection between our end devices. That's basically after we've made the connection. Internet connection between PC and PC. This is our small network structure. A network range like the one I'm drawing now. It is a lot. That is, for each of our companies. In fact, we can all set up such a small local area network. That is to say, there are many companies, like the ones we mentioned earlier. Every company. In fact, it is the same networking process. Then I will copy it a few. This is equivalent to many companies around the world. They are all like this. Then we have to think about a question now. According to a question we just mentioned. Between each company, I both buy some switches like this. Such a device. Then buy some network cables. We connect the terminals together. Between each company PC and PC. They are able to communicate. But now the problem. Each of our companies. If they all form a separate network. Between my company and the company. Will there be a need for mutual visits? Think about this. For example, let me give a simple example. Suppose the company on the far right. Company C. Then it's not a PC. Suppose this is a server of Company C. Then for them, how a company makes money is to open their web services to the outside world. That is, I don't care whether it's advertising or anything else. In short, for the user, I just give them access. That is between our company. There is a need for mutual visits. That's the problem now. As we just said, between businesses. If we were really just building alone, a small local area network, such a network range, that actually my business. Companies cannot communicate with each other. That's the network of each of our companies. In fact, the future needs to be connected. For example, as a server of C company, there are people from all over the world who want to visit Company C. But its companies are not everywhere. How to connect between different companies? You can't directly pull a network cable or an optical fiber. I am connecting from my device to Company C's device. Certainly not. So how do we connect now? We now seem to. I can't handle it myself. Then there is a new business. This new business is the operator's business. When will everyone learn IE in the future? Our many courses, or a lot of technology, will be aimed at the operator's environment, to deploy the network. So everyone must know. In the face of the time when we are now surfing the internet, we use the carrier's internet. The internet is run by the nation, or deployed and built by operators all over the world. We call it ISP. Our country's largest electronic information operator. All have the right to build the overall network. Purchase equipment, laying line construction equipment. Everything they have. Such infrastructure. So say. We are now actually. All operators' networks are used. What is the operator doing? They actually do the same job as a courier company. I will give you a simple example. You want to send a courier from area A. Or you want to send something from area A to area B. Then you have two options. One is that you fly, holding this thing. Sit all the way to area B. Hand over to the opponent. The other one is that you can hand it over to the logistics company. Let them help you forward. Data communication is the same. It can be used to pull a bare fiber. Pull it from area A to area B. But then, first, you don't have infrastructure rights. You do not have the right to connect the device privately. Second, the cost is too high. You can't afford it. So actually, the carrier does the job of the courier company. But in our network industry, sounds a bit more high-end. The operator is for everyone in the country. It all offers the same business. But the business is the same. Fees are different. Still distinguish between low-level and higher-level users. How is the connection between the operator and the operator? We will also connect like this. Not through a VPN. But if you say VPN, it also fits in my picture. Because we are local intranets, right? If the same company, intranet and intranet, want to communicate with each other, we generally use a VPN. But that's not what we're talking about today. What we're talking about today. For example, I go to visit C company from ThinkMo. There is no VPN between us. Let's take a simple example. For example, these devices on the far left. This is a company in region A. The ones on the right are assumed to be from the B region. Then we do now. When deploying and building equipment, our company is in region A. I will connect to one of our company's export devices. That is our company. In the future, there will be a device called a router. We generally draw a circle to represent a router. Then I would connect to the company's outlet. And this router for this egress. In the future, it will be connected to the network of the operator. Make a connection with the operator's equipment. Then in the future we can follow. The operator's network is connected. That includes the same for region B. I will also connect to a device exported by my company now. It's the same for me. I drew it all for you. Our connection. Connected to each of our cities. In the access equipment provided by the operator. That's actually equivalent to passing this way. We are connected. For a device like this we speak. The operator is also the equipment here. I won't draw anymore. Let's just understand. There are many cities in our country. So the future is for every city. Will come and go by the operator's business. Open it up as a whole. The operator is responsible for each of our cities. Interconnection between every city and every city. Then they're the ones who pay for the equipment we use. Now the operators have already built overall network architecture. Everyone needs to know this first. That's how we get online now. How do I get access from area A? For example, a server in region B, carrier-based network, is equivalent to. Actually now we have achieved. We have interconnected devices across the country. So everyone can understand. Between cities. Via the lines laid by future operators. We're already connected. For example, now I am in area A. If I am currently in region A, one of my devices wants to access this C company. We need money to do business. I just need to spend money now to handle the corresponding business of the operator. For example, how many megabytes of fixed bandwidth do I have? How much will I pay for the annual fee? Assign me an address in the future. I will leave this device after I surf the internet. Then you can go online. It is equivalent to after we access the operator. According to our different needs. Can handle different paid services corresponding to operators. Locally my device is connected to the carrier. The operators in various places are connected by themselves. Then we can rely on the original operator. Achieve our nationwide connected information devices. and tell everyone, whichever operator, their overall business can be connected the future. No matter which operator you are dealing with. The official website. All servers that provide access services to the outside world. You can all access. This is what we call one reason why the online world is connected to each other. It's here. This is what we're talking about as a whole. Interconnection between cities. In fact, everyone can imagine. We have a division of regions. Generally speaking, we put every company or every organization, unit organization. It can even be said that it can be as small as every family. A network range we are currently in. I circled in red. This is a local area network. It is a very small network range. We know that as network engineers. Our first step in the future may be to enter a business. To start from the most basic network workers. You will often hear a term called enterprise network or campus network. That actually, they can be said to be a concept in the local area network. That, for example, I put an organizational structure in a local area network, run in the overall campus network. We call it a campus network. Used in a corporate network. It's called an enterprise network. But actually we run the strategy. Some commands to configure. And the overall planning thinking is not too bad. They are all within a local area network. For network architectures like ours. Configuration to go. So first we need to understand the concept. That is in our city. Our overall network architecture. We call it a metropolitan area network. One of our classmates mentioned VPNs before. VPNs in their oldest. There is another means to replace it. If you connect two businesses within a city, we really have bare fiber access. That is, we directly use the dedicated line of the real line. Let's go to Las Vegas and build a line. Then what we said really goes through bare fiber. Connect two different intranets. In fact, it is all within the metropolitan area network. Some operations. Because it is expensive. The network between our cities is called a metropolitan area network. But now the word mentioned a little less. Because for us, in fact, in the current large environment, we only divide the intranet. That is our local area network. And wide area network. So what is a wide area network? Suppose now that I draw this picture. Covers many cities. Overall, it covers the whole country. For our country's operators. In the future, we will also communicate with operators in other countries. Operators in other countries will communicate with operators in other countries. Until the whole world. After all operators in various countries are connected. In fact, it can be achieved worldwide. Everything is connected. In fact, this architecture diagram we are drawing now, although simple, regardless of the architecture you will see later, how huge. From our macro perspective, it's all like this. But what we said does impose some limitations. But we logically, if no restrictions are made, our network communication is really like this. No matter how complex the network architecture you will face in the future. Actually, from a higher point of view. Actually, this is the picture. For example, we will be in the local area network in the future. You will learn a lot of techniques. There will also be many under the WAN. We will also have a lot of intranet and wide area network access. That includes for operators. Data center. There will be some different technical points to explain the subject we are talking about today. In fact, it's about a theme. It is a theme of the interconnection of all things. Sometimes we often hear a sentence, Internet of Everything. I always feel a little bit mystical. But please pay attention. What we say now. Access to everything on the Internet. All data. It's really up to us one by one. Connected by real physical lines. Equipment and equipment. Really real device. Through each other. Real physical wiring. Then our world. It is really such a network structure. It's a very large online world. This is also for us as network workers. Why we can have high salaries in the future. There could be a reason for a more challenging job. Because our network is really very large. That's why we only have internet access on our computers. Access your business from any device in the world. As long as it provides access to the outside world. With your permission. Because everyone's network. We are all connected by carriers. There is no doubt about this. Each country. Now all our access needs are implemented by the operator. If no operator, no access to the operator's business, then we can only be in one LAN. That for now. Some of our business models for various companies and business type. It's all illegal. Because now we are the age of the Internet as a whole. All business is now done online. This is an interconnected state. Mentioned above. It's all about the overall architecture of the network before the class. What you need to know. The structure we are talking about today is very large. But throughout the NA stage, we will only learn a small piece of knowledge on a small scale. That is, in the overall stage of our CCNA. What we talked about today. Between operators and operators. Within the operator. Between the future local area network and our operators. All technology are not involved in the NA stage. All the techniques we have learned. They only exist in such a small local area network. First of all, everyone should be clear. What do we use the technology we have learned at this stage? When everyone learns NP and IE in the future, knowledge will gradually expand to the outside world. That for us. In fact, in a small area. That is, in the future, you will be in a corporate network. Do some of the most basic configurations. In the enterprise network. This is what we do in the NA phase. We can divide the network as a whole into 3 areas. The first is called a local area network. Local area network. We are now relatively close. We will have a unified management model in the future. To provide services for a unified business. Equivalent to this is by our engineers. A network built in-house. Then whether you are a small business or medium-sized business, large enterprise, no matter what your network architecture looks like, you are a local area network. Then secondly, for our metropolitan area network. Between cities. Our geographic range is relatively farther. But we say the concept of now. Gradually eliminated. What about us now? Why we don't go anymore? What about the word metropolitan area network? Because whether it is a metropolitan area network or what we call the wide area network now, we're actually referring to both the operator's business. Because in fact the metropolitan area network is also based on the operator's equipment. Network interconnection. So it's also the operator's service. The WAN is also a service of the operator. So we can only distinguish now a network range that we have built ourselves and the range of operators. So we only have one LAN and the concept of wide area network. Therefore, the metropolitan area network is relatively old. That is still our WAN has not developed to at such a level now. Once the metropolitan area network is still brilliant. Now we will no longer mention this concept. Above are some of our communication concepts. Knowledge of wireless in Cisco. I should talk about it in IE. There will be no wireless part in our NA. Just do a simple extracurricular understanding. We've covered communication concepts and communication architecture. Then we'll get started. Learning of communication principles. That is, how does it work? Why can? What parameters are there as a support? This is what we will learn later. We've been repeating a word today. Operator. Other than the operator. We also mentioned a lot of network devices today. Such as routers. Such as switch. For example, these PCs in our terminal. First, let's briefly talk about history. From the early days of our entire network development. In fact, when the computer was first born. Not for network communication. It just acts as a real computer. Used for high-speed mathematical operations. Physical operation. And that it was actually prepared for military and scientific research. It has many formulas. What we humans are best at is creating and using tools. We call the possible formula developed. The parameters also came out. And how to calculate also calculated. Computers have also developed. Later, you can calculate the launch path of the missile, etc. We can make computers later as a real computing device and can store a large amount of data. Later, as we slowly develop, the team of scientists hopes to put the whole computer synchronize data. Because if the core data is destroyed, that's a very serious price. So the Ministry of Defense came up with the demand. They want to synchronize the overall data. It is hoped that the synchronization of information can be achieved by some means. Earliest network. We are through satellite-based synchronization. But for now it won't work. That cost too much. So the network is actually developing slowly. Did not start with computers. Network now. Then you can go online. Not like this. You are looking at the needs of each era. But in the middle of our process. I won't go into too much detail with you. As the internet began to spread slowly, we'll find that there is a problem. Each country has its own manufacturer of equipment. Such as IBM. That for early. A manufacturer like this. Actually, it was at some point monopolized our overall communications business. We're going to do a meltdown backup. So, that is, the whole network is in the process of communication. Everyone will find. Because there are different network communication standards between different manufacturers. So will lead to, if you go to buy a manufacturer's equipment, you can just buy all the equipment. Only buy from this manufacturer. Because only this one manufacturer's equipment only support this set of communication standards developed by their own manufacturers. Like my number. For example, what format should our information be compiled into? How will each layer of data be transmitted in the future? How is the data of each stage identified in the future? Every manufacturer is different. So if at that time you want to communicate over the network, you have all the equipment, all communication standards, all terminals, buy from the same manufacturer. Otherwise, you will not be able to communicate. Because of the signals passed from device to device. Don't know each other. Interoperability is not possible. So if in such an environment, every manufacturer both individually manufacture their own standard cases, different manufacturers, it is impossible to communicate between devices. Because the data can't understand each other. But you will find The whole world can't just buy equipment from one manufacturer. That's an exaggeration. So, our network actually developed in the beginning. Very severely restricted. So let me tell you this. We'll refer to one of our reference models today. Every time I tell you about this model directly, it may seem abstract to everyone. Every time you start learning, you must start with the model. Every company I just talked to you about. Every manufacturer. Per manufacturer. They have their own standards. It corresponds to the model we are going to talk about today. Because this model is to define the standard of our overall network communication. So everyone learns the model. The first thing to know is that the core problem it solves is when the world follows a set of models for network communication, then in fact it constrains the various manufacturers, their ability to create their own communication standards. Then it is mandatory for us all over the world. All manufacturers follow the same set of standards to produce and manufacture equipment. So in the future we will be building a network. And the network will be traceable when it develops. There is a saying called, "The real enemy of mankind is disorder." When an industry wants to grow rapidly, or to a certain extent, then it must have a set, complete communication standard. Then in our entire curriculum, the first thing we learned was the OSI 7-layer model. To us, at the stage of model making, in fact, business growth is very slow. It's just that we're Messier. Business will grow faster. Which is now for our entire network. We used to have a lot of standards. You can simply take a look. Our once popular IPX standard. First, let me introduce the relationship between them. When we explain the course, we will explain a set of reference models. A 7-layer reference model called OSI, also known as Open Systems Interconnection. Then we explain it according to it because it will be more detailed for the network level division. But what we actually use now, all communications equipment in the world, the only set of industry standards followed, a model called TCP/IP. Everyone should know this. That is to say, we will explain the course according to OSI. But actually we now, using the TCP/IP model, well, these have been eliminated as originally. These are some old network models. But some of what we said was once. Why are there so many? In the early days of our overall network development, there is no set of standards in the network industry. Therefore, a set of standards is urgently needed. Standards proposed by brands, manufacturers, or organizational units. Everyone doesn't care about this. As long as there is now a set of standards available worldwide, all equipment is standardized. As a consumer, one of our thoughts. So around 1977, ARPANET proposes a set of standards called the TCP/IP standard. Just want all network devices. In the end, communication is carried out according to this standard. But it was not adopted. Because for each manufacturer, in the midst of development, suddenly come up with a set of standards. Then it is equivalent to all their equipment cannot be used. Manufacturers' equipment have their own standards. So it won't follow other standards. But you will find the whole trend of our world as a whole must be in order. Standardization is an irreducible step. So, ARPANET as the originator of the network model, they continue to push their own TCP/IP model all the time. Until the second half of the same year, the OSI model was also proposed. ISO's International Organization for Standardization. This ISO is actually the formulation of our entire industry. Industry standard. That OSI is just one of the standards they propose. This organization is specialized in setting standards. It just so happens that they also set the standards for the networking industry. Nothing more. These two are the network models we are going to learn. So what is a network model? That is to say, our current network. What set of standards will be used for communication in the future? For example, I am now going to generate an application data with a lecture program. How should each layer of this application data be encapsulated? How to transmit the final data in accordance with our network communication specifications? How to achieve communication according to our set of standards? This is the model that exists for communication. The meaning and value of existence. The communication standard we actually use now is TCP/IP. Let me stress again. When we explain, we will start with OSI. So let's make a network model, like our OSI reference model today. Just for first unify a standard for our current overall technology. Next, we will divide the hierarchy. What function should we accomplish in each layer? Make a command. The third convenience is to teach everyone now. If the overall knowledge of the network is framed, smashed together to talk, it will be difficult for you to understand. Then, according to our current level of division, I will tell you about each layer individually. Then it will be easier for you to understand. So it is from the teaching direction. Is also relatively simple. But actually OSI is more about helping us provide a means of fault location. In the future, when everyone learns IE, they will go to the experiment. If you haven't worked yet, no real troubleshooting experience, then maybe a little blur on it. Then in the future, you will execute it when you arrive in IE. Or will go to the configuration of some experiments. Then you need to quickly locate. For example, there is no internet connection. Where is the network not working? We need to troubleshoot quickly. We generally have two methods. Top down, then bottom up. Generally speaking, if we rule out layer 2 failures, layer 4 failure, generally speaking, we can quickly locate. Now it's a 3-tier fault. Because the upper 3 floors we will talk about today. It has nothing to do with our network communication. That is when we troubleshoot. We're not going to see if there's a problem here. Then look up to see if there is any problem. Then look up. Usually not so. We all read above and below. If there is no problem above and below, that's the problem in the middle. Since the division of each layer is very clear, then each layer will have some fixed inspection methods. It will help us to quickly locate network faults in the future. This is the meaning of the existence of the OSI reference model. Then we start to formally talk about this model. The OSI reference model has 7 layers. This is mandatory for everyone to remember. Must meet NA this stage as a whole for 1 month. You have to remember these 7 layers. First, follow us from the bottom first. The physical layer. We call it the first layer. Further up, this is called the second floor and the third floor. Suppose I learned a layer 2 technology. We usually mean I learned a technique of data practice floor. Suppose I learned a 3-layer technique. Actually means I learned a network layer technology. What we are learning refers to the hierarchy in OSI. We just talked about a model called TCP/IP. So although we now using this set of models, but it's in the whole model. For our 7 layers, a merge. It merges our first and second layers into one network interface layer. or data interface layer. Layer 2 refers to the network layer. Layer 3 is the transport layer. And merge the upper 3 layers into one application layer. We call it the big application layer. So although we are using TCP/IP now, but when we call it technology, it's not called according to the second and third layers. We are still in accordance with the second layer. Is the data column drop layer. The third layer is called the network layer. Here are some habits of our spoken language. The future of our overall data communication. According to our overall hierarchy. Hierarchy means that each layer is carried out sequentially. Let's go back to this picture. Let's start to explain layer by layer. I first talk about the most basic physical layer. For the physical layer, it is slightly easier to understand. For example, for the most basic physical layer, the physical layer studies. For example, how is the computer connected to the switch? What is this device in the middle? Or the middle wire is a network wire. We call it twisted pair. Inside is copper core. Then why do I plug in a twisted pair and it can communicate? Think about this. Where did this rule come from? This is the standard defined by our physical layer. If for the future, how does it transmit data? We're going to stipulate now. Such a line. How did it get on our device? As a network device. It has a network port. This network interface on our computer is called a network card. Now this crystal head has to be plugged into the network ports of both of us, so that communication can take place. This network port is an indispensable element in communication. It is also defined by our physical layer. That is to say, there is definitely not a random line in the middle. There are also production standards. When the network cable is produced, we also have the order to say so. These things are specified by our reference model. That's actually done by our TCP/IP. In this reference model, in the network interface layer, physical layer specification. But we are still talking about OSI. For OSI, the physical layer regulates some transmission media, network interface and specifications. For example, on the internet, I pass 010101. It's like I'm actually sending an electrical signal. In the future, what your device receives is obviously an electrical signal. How can I convert it into data? First of all, this network port should put this 0101. To convert it, I want to convert the high and low battery to 0101. Then compile it on the computer. Transfer and convey and read upwards. So it is a whole set of complete process. Then all standards pertaining to the upper layer of our physical communication hardware are defined by the physical layer. It is equivalent to the standard that regulates our overall transmission medium, device-to-device interconnection. How about the network cable? What does it look like? How to make a crystal head? In what line order? These standards must be formulated. This is what the physical layer does. There are many transmission media in the physical layer, such as cable and fiber. In the future, everyone will know if they learn wireless. We can also propagation based on air as the transmission medium. So we physical layer. The whole has the existence of a transmission medium. The transmission medium can both realize the interconnection between devices' data transmission. This is what the physical layer can do. But it also has some disadvantages. For example, let me give a simple example. I am now this PC. I want to remotely access the server of company C. You see I'm in area A. Right? I am going to access this C company server in B region. I'm going to upload a piece of data now. I passed an electrical signal. High and low battery. Anyway, I go through the network. Send to this device. But we now think about a problem. If the PC sends data again in the future. If I connect to wireless. Maybe my intermediate data is not stable. Or I pass the network cable. There may be some strong electrical equipment. In the middle of the data. Link is unstable. Or there may be some interference. Because after all we're sending electrical signals. We have a most basic word. Called electromagnetic induction. Although some students do not know how to operate. But everyone needs to know. For such an electrical signal. It is very susceptible to strong electrical interference. For example, if you pass some strong power supply in the middle, passing by some high power appliances, then you may be disturbed. Because we say the signal passed. Called high and low battery. You may be passing a high voltage. Then suddenly the low voltage. What does this amount to? Equipment room. Let's say we're actually passing the code for 0101. However, due to the possible instability of the intermediate circuit, you pass 0. Suddenly it was passed to you as 1. Then your entire data transfer is wrong now. Then I now have a data. I want to send from this PC1 in area A to company C. If my data just went out, just arrived on this switch of our company, my data has been disturbed. Already wrong. I don't need to pass this data to the destination. First, the forwarding resources of the operator equipment along the route must be occupied. That same moment. If the intermediate data is subject to some delay, suffered some damage, that's been destroyed right from the source. It doesn't make sense to pass it on. When the C company data is parsed, it's definitely not the same as the original analysis. It's like you sometimes download some files online. Maybe due to unstable network in the middle. Sometimes the files get corrupted after unzipping. Among them, you may be missing 1 or 2 data. May result in corruption of your entire data. Then you will actually find that it is not optimized. It is also equivalent to the data in my middle. Ran so far. But after reaching the destination. But could not be successfully parsed. Then in fact your one network communication. Already interrupted. So we'll find out now. If your data itself is wrong. Then there is no need to reach the destination. Then here comes the problem. As a network device. How can I know that there is a problem? With the data in transit. We need a behavior mechanism now. Everyone will find. The physical layer can, of course, solve the interconnection between devices and pass data. But if we make mistakes in the data, cannot be detected. Let's take a look at the data link layer. Is it possible to achieve such a function? For example, now one of my data sent from my PC to the middle switch. For switches, the switches we usually come into contact with in NA. It is a very standard layer 2 device. We should not detect 3-layer features at the NA stage. It is a layer 2 device. That's for layer 2 devices. In fact it is. Working in the data link layer we just talked about. Then in the data link layer, we will have a function called error detection. That is, the data will be sent in the future. We will run this data once. Integrity check. We will mention today what kind of a mechanism to perform this check. Once the data is, the whole is sent to the middle switch. The switch will be on layer 2 to check the integrity of this data. So if for our data, by checking I think this data is complete. This is just one of the parameters. If this parameter passes validation, At least this data can be. Then send it to you. If it does not pass the verification here, that proves that your intermediate data is physically damaged. Then the data will be lost directly. Remember this. That is, for our data link layer, it has a very important role. It is possible to complete an error detection. Second, it has another function. On our overall data link layer, there will be a very iconic parameter called MAC address. What's the use of this address? I give an example. For example, there is a data in the future sent from outside. I sent a data to Company C. Company C gave me back the package. The packet that Company C sent back to me was sent from the router. How do I know this data is sent to PC1? Or PC2? Or PC3? As a switch, it has a communication standard for data forwarding. It is called viewing the MAC address of the peer for data forwarding. That is, in the future we can be on the second floor, have a MAC address as an in-range location function on a small link. Every one of our PCs, there will be a different MAC address in the future. Then a data will be sent in the future. If you are going to access the MAC of PC1, I can accurately locate your current PC1, equivalent to our MAC address on the second floor. It is to provide us with address information on a link. This is called a MAC address. It is the function of realizing precise positioning. For now, we have two functions on the second floor. The first one can implement error detection. Secondly, the standard precise positioning function can be realized. But it has another problem. We all know the devices on the link. That is to say, it is now within a range. These devices connected through a switch. We can locate by MAC address. Please pay attention. We generally refer to switches. Everyone has to think of the MAC address. Routers mentioned in the future. You have to think of IP addresses. IP address, and we'll talk about it later. For us, what do they actually represent? A router represents a layer 3 device. Then, in 3 layers, we have an important parameter called IP. A switch represents a layer 2 device. On the second layer, which is the data link layer, we have an important parameter called the MAC address. So you need to put these two parameters and two devices working on different levels to match. That is, for a device on the link, it cannot cross this link. That's what we just said. Is a data to the network connected to the switch. The switch can be judged. Information about the MAC addresses that are now connected to these terminals. But once you get rid of the whole switch now, as long as you go through a router's interface, MAC addresses are relatively useless. That is, the MAC address is to work within our scope. I'll be more straightforward. In the future, if you this PC, I want to find the server of Company C in region B. You can't find it by relying on the MAC address. That is to say, the MAC address cannot access a remote device. It can only access the device in front of it and connect it through the switch within a network. Such an address, it can be found. Broadly speaking, it cannot provide address identification. Then now, there is no way for us to complete the corresponding functions on the second floor. We're going to look up for the second floor one of the first functions it can perform. We can find bugs, implement an error detection. If there is a problem with this data, I lost this data, but I can't go any further. What is the next step? For example, I now send a message to the peer. Then my message is damaged in the middle. But for the sender device, this data has been sent. Some device lost the data in the middle. Then this device needs to notify me. This data is not passed to the destination, but for the second floor. It can only be responsible for throwing this data away. It has no way to notify the original device. So this is a function that the second layer cannot complete. This is the first one. The second one is like what I just told you. There is no way for a MAC address from our macro, or to analyze the address information from a global perspective. That is, its scope of action is relatively narrow. Precise but too small. What kind of address do we use for identification? We are on the third floor. There will also be a parameter on the network layer. It will also carry an address information. IP address. So for IP addresses, the scope in which it takes effect. Not on a link. It does not take effect within the scope of such a link. Rather, in the process of passing all data as a whole, it will take effect. But for our MAC address, our data throughout the transfer process, MAC addresses are subject to change. For example, you are now from region A. Send a courier to area B. For example, you are in the first middle school in area A. It is the second middle school in the province of B region. So, for example, there is a man named Tom. Another person's name is Mary. Tom from the first middle school, Mary from the second middle school. This is actually the equivalent of an IP address. Throughout our express logistics delivery process, your recipients and senders never change. But for the middle, for example, if you come from area A, then you arrive at transfer station number 1. Then pass through transfer station number 2 and transfer station number 3. Then you end up in region B. Then in it, you will go through a lot of different links. Then on each link, your MAC address will be changed. Just like which transfer station you arrive at in your logistics information. Each stage of this information has a source and a purpose. Equivalent to you going from transfer station 1 to transfer station 2. You are now sending a small message. It is also equivalent to reporting your data every time you also has a source and a purpose. This is equivalent to the concept of a small scope transfer, like a MAC. On each link, we will all have a source MAC and a destination MAC. But for our entire data transfer process, we will only have one source IP and one destination IP. Is equivalent to the effective range of the MAC address is relatively small, but the scope of our IP address is valid during the entire transfer. Its address information will not change. It's on our whole one data location, because we will learn the corresponding configuration later. But for the earliest, even if people don't fully understand their scope, but first you have to be clear. Can't distinguish IP from MAC. You need to know what they do. Otherwise it will be difficult to learn. Let me stress again. During a data transfer, MAC address it may change frequently, but the IP address is definitely fixed. This is what we call an IP address. It's a coordinated plan. This is the first concept of our 3 layers. IP address. There is a second concept in the second 3 layers. Routing. Routing means simple. I'll give you an example. Just now I sent a data from here. How can this data finally reach the C company server? This thing is called routing. That is an address for our destination in the future. I was able to query this data. We have a concept called routing table. Query routing table for data forwarding can ensure that the final data, original destination, that is to say, the data is sent If there is no concept of routing, I actually don't know how to go this route. We will learn a table. Routing table. We query according to the routing table. And forwarded. We can do it. The future arrives on every device in the middle. Note that these are the operator's equipment in the middle. We only need to go through the equipment to check the table. Then locate the next device. Our entire internet transmission. It's a form called a baton. One device to another. To another device. There are several transits along the way. And finally reach the destination. We call it a baton transfer form. Then the baton is to rely on routing. Relays that come and go. Or complete data forwarding. This is a concept we will learn in the future. We will also talk about a basic concept of routing today. It is also a network segment problem. So for IP and MAC. Don't think that these two parameters are separated. For example, I'm going to communicate. Can only have IP or only MAC. This is not possible. In the future, we will truly deliver effective business data. Both addresses are definitely needed. We will learn a message in the NA phase. Then there is a packet called ARP. In the future, everyone will be exposed to some data. You will find that this data may not have 3 layers. That is, there is no such IP address. But we call data like this. Do not call our future business data. Business data is the future that really carries your business traffic. For example, if you visit Company C on your computer, this data is called business data for Company C. For such data, the top layer of your data is the application layer. Has real data content. Then, for such data, either MAC address or IP address. Must have. It's just that we'll learn some protocols in the future. In part of the agreement you will find. It seems that some protocols seem to only have MAC. No IP. It doesn't mean that the two of them can be one less. When we will learn later. Let me explain to you. Let's summarize the network layer. What the network layer can achieve. First, provide an IP address. To locate a device's location globally. We can achieve forwarding. Locate a device. Next is routing. This is the function of our 3 layers. But we still have 3 layers of functions that cannot be achieved. We can clearly see. What about 3 layers? The first feature we can't implement is called error correction. Our second floor. For example, sent a data. If this data is wrong, it was lost by the switch. Equivalent to at the data link layer. An error detection was made. And lost the data. But there is no way for the third floor. Corrected for this data. Correction is to tell the original device that the data has not been sent, need to post again. We call this correction. The 3-layer network layer can't do it. The second is that the network layer still has no way to implement another function. For one of our devices, if I'm opening multiple apps, it is impossible to distinguish. For example, now I take this PC3 as an example. I have 2 applications open at the same time on PC3. One is WeChat. One is WhatsApp. Suppose I have a unique IP address. Not to mention any other conversions today. Suppose I now have some corresponding servers on the right. On the far left is the WeChat server. In the middle this is WhatsApp. When I make data access in the future, let's restore the process of accessing. Suppose my WeChat wants to access the WeChat server. And now my WhatsApp goes to access to WhatsApp server. I can communicate. I have to get on board and connect to the server. My chat history and account password are kept inside. I have to log into this server first. So now we have a problem. For our 3-layer network layer, provides something called an IP address. Then it can uniquely locate the location of our PC. So for WeChat and WhatsApp, they're going to give me back. My WeChat reply package is to this PC. Because now the IP address of this PC sent me. My WhatsApp package is also returned to this PC. Then for our network layer. Now there are 2 servers at the same time. I gave you 2 pieces of data. Do you know which data is WeChat? Which data is WhatsApp? This creates a new problem. That is, now only if there is only one IP address. Then all future business you visit can communicate with you. When your data is passed, the server addresses of WeChat and WhatsApp are different. You can find both of them. But when they return to you, you only have one IP address. Ask them for the data. How to distinguish your device. Next we look at the transport layer. In the OSI reference model. That is, the network layer now has only one IP address and a routing function. We don't have any other features. We have the concept of a port. The transport layer can provide a new parameter or a new variable. Port. For example, I am currently local. Give WeChat a parameter called X. Give this WhatsApp a parameter called Y. In the future, when I have a communication visit, I will take my local IP address plus now this port to communicate with WeChat. Then in the future, when WeChat replies to me with data, it puts the data back on my X. If I want to communicate with WhatsApp on my local PC in the future, I'll take Y to communicate with it. Then the future WhatsApp server, when replying to me with data, it takes this data. Reply to this Y on my local is equivalent to. Now although we only have one IP address, but we can build on this. Initiates or expands the concept of a port. We will talk about this later. But it won't go into too much detail. Just as everyone understands. Equivalent to our present. Developed a new variable. On that port, we can have different port IDs later. First of all, you need to know. Every time I want to access a process locally on the device, actually I will have a corresponding port. Is a randomly initiated port. A random port greater than 1024. Then this port is recorded locally. Then I will carry this port when communicating. My local generated port. Communicate with the outside world. Of course, the peer you access also has a port. Communication between our data and data. Each layer must be parameter equivalent. But for WeChat and WhatsApp, their ports are also fixed. For example, if you go to visit the web service of Company C, you are actually accessing the 80 HCP of Company C or 43 HCPS such ports. It will reply to the corresponding port in the future. For the same device, I receive different data on different ports. If the port number is X, give it to WeChat. If it is Y, give it to WhatsApp. Some students will talk about UDP and TCP. Our 2 transport layer protocols. One is TCP. One is UDP. This is one of our transport controls. A user packet. We will also mention briefly to mention both of them later. But today I will give you a general introduction. That is, what function can it achieve? This is one of. Then there is another. What we just talked about is, for the data link layer, we can perform an error detection at the switch. As a switch, it is a data link layer product. Implement error detection. If once it fails the test, I lost my bag. So how do I correct it? We will have two protocols at the transport layer. Just like a classmate said a while ago called TCP. One called UDP. If the future transport layer, we choose the TCP protocol, then it can be retransmitted. Once our transport layer uses TCP for encapsulation in the future, halfway through your data transfer, the data is lost. We are able to base on this agreement data retransmission, but not if it is UDP. Data is lost. You just have an impression. Because for the fourth layer, it should go to IE and then go to contact. And we can't learn many functions of the fourth floor. This is the function of our 4 layers. Next, let's take a look at the 3 layers above. But we as engineers now, what we focus on is actually the second, third, and fourth floors. More precisely, in fact, we focus more on the second and third floors. First you need to know, as the upper 3 layers. Actually it's more developed. That's what some developers do. Some corresponding processing. For our web workers, we are more concerned about the network communication. That is, the network can't get through. As long as we go down to the 4th floor, we can do it well. This network communication is no problem. As for the future between your applications, how to verify, including between your apps. Specifically, what means carry out some corresponding control. So how to compile, how to decode, how to do some compatibility. This is what the application layer needs to do. That's what developers do. But let's briefly talk about the first 3 layers. But I won't be too specific. We just mentioned a concept. Local. We have a port number, an identity. Come and go to differentiate between different apps on my device. But we actually have a new problem. Between some different applications, we have to distinguish one thing. Process. Did you know this stuff? For us now, we open a page of the Google server. Let's say I'm searching for a word now. You will find that there are many corresponding options below. That is, I am now searching for it through the web. Then please pay attention. It's different, like some options are actually different subprocesses. That is actually for them. You are accessing the server of Google, but you are accessing a different process in the Google server. So it is equivalent to, although you are also accessing the server of Google now, but actually for your device. In fact, your current device, different processes are started. They are all Google. That's for the port number. The port of our transport layer. It can only be based on our service, or positioning based on application. So what exactly is this service? It can't be done. How do you do it? Let's move on to the session layer. The session layer can realize our different application processes. That is, the distinction between service processes and service processes. It's enough for you to understand. For the process. In fact, it is also a process. But it's a subservice in the process. There are still some differences. That is, strictly speaking, a process that everyone understands. In fact, in our broad sense, a concept of service. But for the process, it also differentiates between subservices in a process or subprocess. Then for it, our transport layer can't do it. Need to use session layer. Looking further up, there is a layer called the presentation layer. The presentation layer is responsible for compiling and decoding data. For example, suppose I'm on the left and this is a PC. Then this PC assumes that The installed system is a Windows system. Under Windows, we can actually implement software-to-software communication. First, you need to know both PCs are Windows system, able to communicate with each other. Everybody knows. Now the server is actually based on Linux system. We're going to knock orders with Cisco's equipment in the future. Actually, we are using Cisco iOS system. It is also a secondary modification based on Linux. So in fact, 4 different systems. They all have differences between the underlying systems. Like me now. I downloaded a Windows system on the PC side of my device. Installed a WhatsApp. For example, the PC here. I'm on a desktop version of Linux. Also installed a WhatsApp. So even for the same software as WhatsApp. But it's actually a different underlying operating system. That is for us. Even if our underlying architecture is different. But in fact everyone knows. It doesn't affect our communication with each other. Then here comes the problem. Data encoding format under our Windows. That is the encoding format of WhatsApp. It is different from the Linux system. Then if the encoding form, under different circumstances, data looks different. How did you communicate? That is, how do you connect future data? There will be a session layer among us. It will be dedicated to compiling and decoding our data. Then put our different underlying systems under all data. Convert to a standard format. Communicate based on the middle. It's like people going to translate the language of a country. Become a universal language. We all translate into a standard language. Communication is the same. Let's just understand. That is, we can implement between different operating systems in different underlying environments. It will not affect the data of the upper application software. I can convert the representation to a generic standard encoding format. This is our 6th floor. The last one is our 7-layer application layer. The application layer actually implements relatively many functions. Let's start with the first function. The application layer is the first to bear the brunt of the problem to be solved. It's the problem that the lower models can't solve. I just mentioned to you. I say if the future is at the transport layer. We use a protocol like UDP. In fact, it has no way to complete the data retransmission. If a data fails the data link layer check. Then if the 4 layers choose TCP, it is capable of retransmission. If it is UDP, it cannot be retransmitted. For example, we are now a WeChat chat box. I am sending data to others now. If at some point my internet is not very good, then there will be a red exclamation mark in front of the message. After we artificially click on this exclamation mark, data will be resent. That is to say, for our data, if I am within the stipulated time, I didn't send this data. It is equivalent to my sending failed. I don't automatically send. That is to say, these agreements we are now following, or the lower level, it can't solve this problem. Then only by means of this application. Develop an exclamation mark here. Such a button. Make you click this button artificially. As long as you automatically resend the data for you. This is equivalent to a retransmission of the data. That is, your data is in the process of transmission. Due to network problems, there was a problem with the data transfer. But this data will not be in the situation that the network gets better again. Automatically deliver for you. We cannot retransmit. We all retransmit manually. Then, for the lower level. If you are chatting on WeChat now, the protocol we choose now is UDP. Automatic retransmission is not possible. Application layer. Develop some tools. That is, some means of access. Help you achieve retransmission. Is to rely on manual resending. This is called an error correction process. At the application software level. If for you during the video, network stuck for a while, it can't be passed. Because for video, this timely flow. If you lose it, lose it. No need to retransmit. So different business flows. There will be some different standards in the future. So does this thing need to be retransmitted? Are defined by the software. Like WeChat thinks you are sending data. Or some voice messages sent. Is capable of retransmission. Then they provide the corresponding button. If you are making a voice call. If several packets are lost in it. Network stuck a few times. They see no need for retransmission. They won't give you corresponding retransmission measures. Then you lose this data and lose it completely. This is our reference model for OSI. In addition to this function, the application layer. And others. For example, different data can be generated. Are different programs in the future. Or between different applications. Our data are all different. I sent a message on WhatsApp. What I generate is based on the data generated by the WhatsApp application. WhatsApp it will conform to some of the specifications of an application like WhatsApp. That is, the specifications made by some applications. Between the different applications, specifications are different. Based on our current application layer, can generate different data. And one last point. It's our authentication or encryption method. Actually, for authentication and encryption, we prefer to refer to the large application layer. Actually, for a function like this. In fact, we still follow the overall TCP/IP standard. What we call the function implemented by the large application layer. For example, account password. All are based on the verification methods set by our large application layer. Then provide you with an identity verification in the future. Here's what we're talking about. Last encryption. Speaking of which, let's make a summary. We are now a 7-tier architecture. In the 7 layers. Each layer is able to implement the problems of each layer. In other words, it can solve the problem of each layer. The physical layer solves the transmission medium pair. The physical layer connects devices. Transmit our data signals. Then the data link layer. We have 2 more important parameters. A MAC address. Another is to provide the function of error detection. For the network layer, there is a core parameter called IP address. Secondly, there is a function called routing. There are 2 major protocols at the transport layer. One is TCP and the other is UDP. We have another protocol station called TCP/IP. In fact, it is the TCP protocol used at the transport layer. And network layer IP protocol. IP protocol is called Internet Protocol. And our transport layer, what we call the TCP protocol. 2 major protocols make up such a name. This is our transmission control protocol. What we are using now. In fact, it is the protocol station of IPv4. That is for us now. These 2 agreements are very large. Represents the core of our entire data communication learning. The 2 most powerful agreements. Everyone is relatively familiar with the IP protocol. Everyone is unfamiliar with TCP. The overall development cycle of the TCP protocol is about 20 years. It can achieve a lot of functions in it. The overall development cycle and design cycle are very long. Actually, we as networkers, in fact, Only about half of the knowledge in TCP can be accessed. The remaining half is for programmers to touch. So such an agreement. Don't ask everyone to fully grasp. Even if you get to IE, you can't learn all the functions of TCP as a whole. So what we are more important is to revolve around us on the second and third floors, to discuss our overall web technology. Of course, the transport layer is also very important. But relatively speaking, there are not as many as the second and third floors. Based on the 7 layers of our current OSI reference model, each layer it can solve the problem of each layer. So the final question. The development cycle of a program is relatively long. Then each layer, it has to choose a specified protocol. Then in theory our application is developed as a whole. If you now go up layer by layer to the application layer, there is one more problem that has not been solved. So basically this app, or this service, don't go online, because it is inherently problematic. In theory, as long as it reaches the application layer, everything in your app, it should have been resolved. Also known as the bug of this software. So sometimes you will find some software needs to be updated all the time. Been going to fix some bugs before. There are some problems during development. Routers and switches are really in terms of devices. There is no essential difference. The difference between them is, from my current point of view, they work differently. For the switches we are talking about now, it can be understood as our layer 2 switch. It works on our data link layer. That is, for a layer 2 switch, it can only process information that sees at most our data link layer. A data to a switch. This packet can only be split to the second layer at most. The contents of the third floor cannot be seen. That is, in this data, all the IPs it offers, including some addressing forwarding, the protocol used by the 4-layer delivery layer. I don't see any of these. I only look at the content in the data link layer. Data forwarding based on IP address. For layer 3 the router receives the data. After the second floor, I will see the third floor. In layer 3, I will check the source IP and destination IP, and query the routing table for forwarding. Switches and routers. At this stage we are. First, the levels of the packets they view are different. It works on the second floor. It works on 3 layers. It sees that packets are split to layer 2. It sees the packets are split into 3 layers. It is based on the MAC address table. Perform data forwarding on the chain. It provides data forwarding throughout network communication based on routing. Because query routing, it's another level. It's not the same concept as our second floor. So just tell everyone. There is no essential difference between a switch and a router.